Okay, guys, so we are back. So as I was saying here, you would choose a suitable scale for the x-axis and a suitable scale for your y-axis. Now on my x-axis here, I use a scale of 1 centimeter equal to 1 unit for the x value. So that's my scale for my x-axis. So you need to write your scale on somewhere on your graph paper. You want to put it at a place where it is not humbugging your work, but it is clear that whosoever is marking your paper can see where it is. So 1 centimeter represents, or if you may, equal 1 unit on the x-axis. So that's the scale for the x-axis. All right, so your y-axis now, as I was saying, when you're choosing your scale for your axis, you want to look at the table. And looking at the table, you want to look, what are the range of values that you have here? For the y values, the range goes from 0 to 64. So it means then on your y-axis, you want to put a scale that can accommodate the values from 0 up to 64. Now, you could decide on a scale of, suppose you want to use 1 centimeter equal 10 units, then that would be entirely up to you. If you figure more or less that you could use a scale which is a little bigger than that, right? You could also decide to do that. All right, so for this axis, which is the y-axis, I'm going to use a scale of 1 centimeter equal to 10 units. So this is for the y. So the scale for my y-axis is 1 centimeter equal to 10 units. All right. Now, so here we would count by 10. So our first, here we would have 10. Next, you would have 20. I would have 20. And 30. And 40. And 50. Then 60. Now we're going all the way up to 64, so you may want to go up to 70 on your y-axis. Then 70. All right. So once you have drawn your axis and you put on your scale, then the next thing now is to plot your points. So what you're going to do now, you're going to look at your x values corresponding to your y values. So 0 corresponds to 0. So the first point would be 0, 0. X equals 0, y equals 0. So the point at which x equals 0 is at the origin, and the point at which y equals 0 is also at the origin. So you want to highlight these points where you are plotting your graph, all right? So I'm going to try to see if I can use so that I don't know if you are able to see. So that would be our first point. Can anybody see the point that I put there? There it is. That's our first point. Now, once you put your point, you need to label your coordinates. So this would be the point 0, 0. All right. So the point 0, 0. All right. So now you need to label the next point, which is x equal to 2 and y equal to 4. So along the x-axis, you look for 2. So you count 1, 2. So this is where you have 2. So you want to go all the way up now to y equal 4. Now, remember now, 1 centimeter would now be 10 units on the y-axis, but you now want 4. So what you have to now consider is those tiny boxes. You have to now think about if 1 centimeter equal to 10 units, one of those tiny boxes is going to be equal to how much? Can anybody tell me?
1.
All right, so if you call one of these 1, then you would have go from 0, then 1, then 2, then 3, then 4. That wouldn't be correct. You want to try something, another number? How many tiny boxes between the centimeter? 2, right? So one of these tiny boxes would be 2. And if you want y equal 4, how many of these tiny boxes you have to go up? So one tiny box is 2. So you count 2, then the next tiny box you will get 4. The next tiny box you'll get 6. Next tiny box you'll get 8, and then you would arrive at 10. Everybody see that? So on your x-axis, you have 2, so you find where the x equal to 2 on your x-axis. Then you're going up now 2 tiny boxes on your in the y direction. So you go 1, and then you go 2. So you will go right here. So your point would be right here. And then now you could label your points based on the coordinates. So you would put the x value first, which is 2. Then you put your y value, which is 4. So that would label that point. All right, so you do the same thing for all your values until you finish all the points. So the next value that we have is x equal 4 and the y equal to 16. So along the x, you move 4 places. So you find 4, but on the y-axis, you want to go up 16. So you know, if you are at 4, you go 1 centimeter up, you would have gone up 10. But you want to go up 16. We know that each of these tiny boxes would be 2. So you can start off at 10, and then you count 10. And you add 2, you get 12. You add 2 more, you get 14. You add 2 more, you get 16. And so you would be right here. Right? And so now you would highlight your points. And then now you could label your point with your coordinates. So here we would have x equal to, we have x equal to 4, and we have y equal to 16. All right, so our next point then would be x equal to 6 and y equal to 36. So let us see if we can find that. So we move along the x-axis, we go to 6, and we're going up y, which is 36. So we know that going up 1 centimeter at a time, that would be 10, but we want 36. So we go up 10, 20, 30, and then now we go up 3 tiny boxes to get the 6. So we go up 2, 4, 6. So we would be right at this point here. All right, so if you highlight that point, then now you label your point as usual. So labeling this point, we would have x equals 6 and y is equal to 36. Guys, I hope you are doing this, you know. And at the end of it, you should plot your points and get a curve, right? All right, so our next value then would be x equal to 8 and y equal to 64. So you go along the x-axis to 8, you're going up 64. So you count by 10, so you have 10, 20, 30, 40, 50, 60, but we want to go up 4 more. So we know each of the tiny box will be 2. So we go up 2 and then 4. And so we would be right here at this point. And so we could highlight now our points. And then now we would label our points. So this point here would be x equal to 8 and y would be equal to 64. All right, and then we close our brackets. Now, having done that, now this is very important, guys. I don't know, I should have mentioned before you started plotting your graph that your graph must be plotted using a pencil. All right, so you should use a pencil to plot your graph. And you want to have a sharp point pencil, and preferably one that they call number 2 pencil. All right. Now, if you have not yet done so, please get a pencil or purchase a pencil for the purpose of plotting your graph. All right, guys. Now, having plot your point, plot your points, then you need to connect these points to give the shape of your diagram. In this case, when you're drawing, if your points are not showing a straight line connection, then you should use a free hand in drawing your curve. Now, if it is a straight line connection that your points are giving you, you may use a ruler to connect the points. But where you see the points are not giving you a straight line, you need to use your free hand with your pencil. So this is going to take some amount of practice. You want to draw freehand with as accurate as possible. Now, when we're drawing our graph with our pencil, we don't use jagged lines, meaning that your line should not look like this when you're drawing it. That's jagged line. We don't use jagged lines for graph. We want to have smooth lines. So once you put down your pencil, you should have a continuous smooth line. That's how you draw your graph, guys. So you don't lift up your points after you put it down. So what we want to do is to draw as accurate as possible a smooth line or a smooth curve for these points. So as I said, practice makes perfect. So you will take your time at first and try to connect your lines, your dots, or should I say your points, as accurate as possible, right? You should get a smooth curve. Now, the more practice you get in drawing your curve will look more accurate. Now, let me see the hands of those who have already connected the dots and get a curve looking like this one here. All right, let's wait some. Who else?
Sorry, I got it.
All right. Now, guys, I want to ensure that you are doing this activity. So I'm going to require that after the class, you send it directly to my WhatsApp. You send me a picture of your graph. Take a picture of your graph and send it to me. I need to see them. All right. Is that clear, students? Right.
How about sir?
I'm not there. Miss Brown?
Yes, sir. Can you hear me?
Yes.
Sir, I have a question. Why don't you start from bottom to top?
Oh, you mean in terms of drawing the curve?
Yes, sir.
It doesn't matter. Wherever you feel comfortable starting, you can start.
Okay.
All right. So it you know, depending on how you practice, you draw it as accurate as possible. So it doesn't matter where you start from. All right. So draw your curve on your graph paper, guys. Take a picture of the curve when you're finished. After the class, that is, when the class ends, you can take a picture and send it to my WhatsApp so that I get a sense of what you're doing. All right. All right. So can we move on from here now? Raise your hand if we are okay with this and we can move on, guys. Okay, good. All right, so I see 2 persons so far. So I'm going to move on and I'm going to clear what I have here. Is that okay, guys? Okay, good. All right. So now this is what our curve is supposed to look like from that graph, right? So if you have drawn your graph correctly, you should get a curve looking like that. All right, so we're looking now at smooth curve or a straight line. All right, now corresponding values for X and Y. So corresponding values for X and Y between values given in the table can be deduced from a smooth curve or a straight line. Let me read that again for you guys. So corresponding values for X and Y between values given in the table can be deduced from a smooth curve or a straight line curve. All right, straight line, that is. All right, what that means. If we want, and let me just go back to the graph or this one. Let's say if you look at this curve, this is the curve that we just drawn from the table. And we know that on the table we use for the X values, we use 0, 2, 4, 6, 8. Those are the X values. So if we look at the table, X values would be, let me see if I can quickly construct a table. All right, so our X values from the table, we have 0, 2, 4, 6, 8. All right, the corresponding Y values we had were 0, 4, 16, the next one would be 36, the next one would be 64. Now, these were values given in the table. But what we're saying, once you have drawn the curve, we can also find other values between these values in the table. So for instance, suppose we say we want to know what the Y value for X equal to 3. Now, 3 is not given in the table, but we noticed that we could find 3 between 0 and 2, right? Sorry, between 2 and 4 rather. So 3, we would have 3 here in the table. It is not given, but we know it would be between this. Now we can use a curve to determine what the value of 3 would correspond to. So we know we look at the x-axis. We're on our x-axis, we're moving, for this scale, we are going up by 2. So we know that if we go to the middle of 2 and 4, we would have 3. So on the x-axis, if we come on the position where 3 would be on the x-axis, we could pretty much draw a line to meet the curve. And then now wherever that line meets the curve, we could come across now and meet our y-axis. And then now we could use that to determine what the value, the Y value would be. And so the Y value would end up somewhere around here, which would be 9, right? Now, to use a curve to determine values between the values on the table, we call this process, we call that process of using the curve interpolation. All right. So that's one way how we can use a curve. We can use it to find values between these values in the table. And doing it that way, we refer to it as interpolation. So the method of deducing values from a smooth curve or a line curve is called interpolation. Now, if we go back, we can also use this curve in another way. Now we know that the range of values, that is in the table for the X values goes from 0 to 8. But suppose you want to find values outside the range. So we want to find value greater than 8. Now, because this is a smooth curve and it is trending in a particular direction, we could use dotted lines to kind of extend the curve based on the direction that it is trending. And then now, we could use that extended line, dotted line, to find value or values outside the range of what is on the table. So out here we could use, say, let's say we try to find what the value 9 corresponds to. So this extended line, we go up, we meet where this extended line is, then we go across, and we determine the value that we should be getting here. All right. Well, apparently this is not very accurate. It's not an accurate extension of the curve. It's supposed to be extending this way. Let me see if I can give a little bit more accuracy to the extension. So it's supposed to be extending this way. All right, that's how it should be look. It should be curving upwards. And so using it this way, we would have 9 would correspond. It should correspond to 81. All right. Because we notice that all of these values, the x values, when you square them, you get the y values. So when you square 0, you get back 0, 0, you square 2, you get 4. You square 4, you get 16, you square 6, you get 36, square 8, you get 64. So if you square 9, you should get 81. So you could actually use a curve to determine the value of 9. Now, when you extend the curve in this way and use it to find values outside the range of the table, this method is called extrapolation. All right, so if we extend the curve so that it follows the general trend, we can estimate the values of x and y, which lies just beyond the range of the given values. All right, and the method of deducing values from a smooth curve or a straight line by extending the curve just beyond the range so that it follows the general trend is called extrapolation. All right, guys, so from this, you should now understand that to find values between the values in the table, you can use a straight line or a curve to find these values, and the method is known as interpolation. And if you extend the curve or the line just beyond the range of the table to find values outside the range of the table, this method is known as extrapolation. Is that clear, guys? Raise your hand if you are understanding exactly what was just said. Raise your hand, guys. Is it clear what is interpolation and extrapolation? Is anyone hearing me? Ms. Waysam, Ms. Caveira? Are you guys hearing
I'm hearing you.
So I'm
in a cement yet, sir.
all right. So interpolation is where, having drawn the curve, any values that fall between the values that are in the table that were not given in the table, you could use the curve to find those values for the y value. That is what we call interpolation, because we are using the curve in between the values of the tables. All right, if you extend the curve from where the curve ends so that you can find values beyond that point, then we say that using the curve in this way is known as extrapolation. All right, does that make it any better for you?
Yes, sir.
All right. So, all right, guys, so we're going to be stopping here for today. And then we'll be continuing with graph, our next class, which is tomorrow. All right, guys, so see you guys